So I'd like to go over how to write an exponential equation from a word problem. So looking at being able to come up with the actual relationship or the actual equation based on the information given to you. So key things for us is that usually comes up with finance or sometimes things like cell growth or bacterial growth or decay, radioactive decay as well. So there's lots of processes in life that follow an exponential relationship, and we have to be able to identify information from a word problem to write the equation. So some reminders for you. Actually, I like blue. This is going to be your initial amount. So that would be your initial deposit or the initial population or what you start with. Okay, so what you're actually starting with. This would be any shift, up or down. But in our word problems, it's usually not there. We don't usually talk about shifting things up or down, so it's usually just the amount you're starting with and then actually having to figure out the rate. That's the other important thing. So this is the rate of increase or decrease. And reminders for you, if b is greater than 1, you get a graph that is increasing. And if b is less than 1, you get a graph that is decreasing. So keep that in mind. You can imagine them on the grids. B less than 1, you have the decreasing graph. B greater than 1, you have the increasing graph. And so in this case, C is often just 0. Okay. How to figure out the rate from the word problem usually involves just playing with the percentages. So to find B for an increase problem, a percentage increase problem, you need to convert the percentage to decimal and add it to 1. So if you're not sure how to convert percentage to decimal, remember that's divide by 100, or move the decimal point 2 spots over. Most of us can do that in our head, but don't be afraid to use the calculator to do, that number divided by 100 to get it. And then the important thing there is that you're actually adding it to 1. So you should get a number that's bigger than 1, like 1.5 or 1.07, whatever it is. So in this case, there's a couple different vocabulary words that we'll look at, but just increase by 5%. If you saw that in the problem's actually increasing by 5%. 5% as a decimal is 0.05, and then I add that to 1. So plus 1 gets me, I'll write it below, gets me b here is equal to 1.05. And be really careful, 5% is not 0.5, that would be 50%. So double check it, and don't be afraid to use the calculator to divide by 100 if you need to. So now that you have b, you could put that into the problem. Here's another vocabulary word, just to think about the phrasing here. It grows in value. Well, if it's growing in value, that means it's actually increasing, so you can think about it going up again. 2%, if we convert that to a decimal, is going to be equal to 0.02. So b is going to be equal to 1 plus 0.02, which is equal to 1.02, and you'd use 1.02 in your equation. How about appreciates? Another big fancy word, but it really does mean that it's gaining value, that it's becoming more valuable in time. So this is also an increase. 20%, if I'm going to convert that to a decimal, that is actually 0.2. So my b is going to be equal to 1 plus 0.2, which is 1.2. And that's what you would use for your equation. Accrues is another word just meaning that it's accumulating, it's getting more valuable as well, it's collecting interest. So accrues interest of 3.5%. 3.5%, if you convert that, is going to be 0.035. Again, divide by 100 if you need to. And your b would be 1 plus 0.035, which is equal to 1.035. And that's what you would use in the equation. Similarly, if you're trying to find b for a percentage decrease problem, where it's becoming less valuable, you're losing or being charged money, convert the percentage into a decimal, again, and subtract from 1. So that's the difference here. We're going to subtract from 1. So you should have a number that's less than 1, like 0.9 or 0.25 or something smaller. So decreasing by 9, again, convert that to a decimal, 0.09. And b is going to be equal to 1 minus 0.09. So in this case, it's going to be equal to 0.91. That's the number you would use for b. Depreciates, the opposite of appreciates. It's actually losing value here again, so this is a decrease. by 12%. 12% would be 0.12. And again, we would subtract it from 1. So that's going to be equal to 0.88. And you would use 0.88 in the equation. Loses 2.8% of its value, so 2.8% is going to be equal to 0.028. B then would be 1 minus 0.028. So here we get 0.972. So again, it's the same every time. To convert it to decimal, just divide by 100. And then you have to think about, am I getting bigger? Am I growing in value? In that case, I'll add it on. Becomes a bigger number. You'll add it to 1. Or is it losing value? Is it getting less? And so you think about subtracting it from 1, get a smaller number. Okay, so putting this information together, let's look at a word problem here. Spencer deposits $200 into a savings account with an interest of 3% per annum. So $200, that's his initial deposit. That's his starting value. So here you already know that A is equal to 200. Savings account with an interest of 3% per annum. So that's going to be where I get my B from. Again, think about converting 3% into a decimal, 0.03. And here, with an interest rate, it's a savings account, so that's the hint here that it's going to be an increasing. So we're going to add it on. My B will be equal to 1 plus 0.03, so 1.03. So our first step, write an equation to represent how much money you will have in that account over time. So I need to figure out some values for money and time. And here I've got my A and my B, remembering that my generic equation is equal to y a times b to the power of x. And usually for finance, we don't worry about a c. There's no information here to talk about shifting, so it would just be c equals 0. So I would say that y is equal to a, which is 200, times b, 1.03. And because I'm doing time, I might say to the power of t. If you put an x there, that would be okay. You could also think about putting, something like value or amount or money at the front if you knew a specific variable. But key thing is, something is equal to 200 times 1.03 to the power of something else. Alright, so I'll leave it as y for now. Use the equation to show how much money you will have in that account in 6 years' time. So, using that equation, 6 years' time, is that going to be y or is that going to be t? Looking for the information they've given me, here I know that t is equal to 6, and I'm looking for how much money. So that's my y equals. I don't know what y equals. So by using the equation, what they want is substitution, like we did with the parabolas. So substitution, I'm going to replace t with 6. So I'm going to write y is equal to 200 times 1.03 to the power of 6. Now you can put that straight into your calculator because we don't need to actually do any arranging. 200 times 1.03 to the power of, you use that little hat key there, 6. And that tells me that in 6 years' time, he'll have about 200, and I'll just round it up, 238.81. So equal to $238.81 in that account. So if you put in the $200 at the start and didn't do anything else, the interest he accumulates, in 6 years' time, he's made $38.8, so $38.81. Okay. Next bit, use this equation to show how many years it will take to reach 500. So use the equation again. They want you to show some substitution. How many years? So now we're looking for time. We don't know what that is. And we're looking for a value of $500. So in that case, that's that he has $500. We know that y is equal to 500. So here, using my equation, instead of writing y, I'll write 500 is equal to 200 times 0.03 to the power of t that we don't know. Now, some of you guys might have the algebra skills to be able to rearrange that, but if you do not, two ways you can do this is one is using solver, and the other one is using the graph. So since we've done graphs with gsolve, I might actually show you solver in this instance. So you're going to want to find the one that says equation on your graph. Graphics calculator, find the one that says equation, and you'll put that in, and I want you to go into solver, so F3 for solver. So we'll try to just use solver here. Rearrange this so I can see at the same time. So in solver, you're just going to type in exactly what you see. So I see 500. My equal sign is right there, the shift, and it's above the decimal. So shift equals 200 times 1.03 to the power of, again, that's the little hat key. Now do not try to find the letter T and type it in there. The only thing you ever use for variables in your calculator is going to be that button right under the red one, just like we do in graphing. So we'll just put an X. Even though it says T, we'll just put an X. Hint, enter. And the next step that's really important is you actually have to press solve. So don't forget that. Pressing solve. So here I've been given some information. I now know that the answer there would be X is equal to 30.99999. So that's pretty close to 31 years. So I might just round that to say that T is equal to 31 years. Don't forget to use the units there. And as a side thing as well, if you did want to graph it, just so you can see that, if we put that equation into using your graphics, you would say 200 times 1.03, again use the hat key, hat to the power of X. So when you're putting them in, it's going to be using the hat key to get the power of X. Right. Graph it, draw it. Again, oh, I can't see anything, that's crap, so let's try zoom auto, see if I can get to where I can actually see something. Here I've got some information, I can see what's going on. I'm not really sure what the scale is, but it should be starting at 200 and increasing from there. So here you could use gsolve, go over, and we're looking for X, so we'd use an xcalc. Our Y value was 500. It's not found. Again, that's just a hint for us. We need to zoom out further. So go ahead and draw it. Zoom out. Zoom out. And we can check the window just to make sure. We know that Y needs to get up to 500, and you can see here that it's not actually at 500 yet. So let's go just to 550 to make sure it's included in that window. Draw. Now we can do gsolve, xcalc 500 for Y, put it in, still not found. Oops. Means we just need to zoom out even further. So draw, and let's make this X max something like 40. Make it bigger, go further in time. And again, gsolve, xcalc 500. And there we are. You can see that same number, 30.999, so close to 31, finally shows up. So those are your two ways you can use the calculator to solve that problem. And don't forget, when you're entering the exponents into the calculator, you need to use the hat key to graph them. I've got one more example if you're interested, otherwise you can get on and start doing some problems yourself. But we'll take a look at this. Oops. Spender, that's probably a good name for this one anyways. Spender has purchased a Batmobile for $5 million. Now he drives it around. The value of the Batmobile is depreciating. It depreciates by 14% each year. So remember, depreciate means it's losing value. And 14%, we could convert that to 0.14. And my b then, because I'm losing value, would be 1 minus 0.14, which is 0.86. He purchased it for $5 million. That's how much the Batmobile is worth at the start. So my a value there is actually 5 million. So if I'm going to write an equation to show the value of the Batmobile over time, let's use v and t. So the value of the Batmobile started at 5 million, and it's going to lose my value 8.86, 1 minus 0.14, to the power of t, to the time. So that's your equation. Use the equation here to find out how much it'll be worth in 10 years' time. So here I'm looking, they told me that t is equal to 10, so let's plug that in. The value is equal to 5 million times 0.86 to the power of 10. And because there's no rearranging there, we can just go straight to the normal calculator and plug that in. 5 million times 0.86 to the power of, using the little hat key, little arrow key, to the power of 10. So this value is going to be 1,106,507. So equal to 1,106,507. We'll just round up to $508, because really the amount of cents that it's worth here is probably not very important, considering it's already over $1 million. So in 10 years' time, he's gone from a $5 million car down to a $1 million car. Next question. Use the equation, so again they want us to show some substitution, to find out how long, so that's t equals question mark, it takes to be worth only half its original value. So there's no other number here, but they've given you some good information, half its original value. So what's that value? That would be 5 million divided by 2, half that value, so 2,500,000, 2.5 million. So that is my v, my value number. So here, plugging that into the equation, 2.5 million, half the original value, is equal to 5 million times 0.86 to the power of 10, to the power of t, because we don't know what t is. And here I would probably use solver again. So go into your main menu, find the one that says equation, go to solver, and we'll enter in exactly what we see. So you can see here they've got a bunch of information in there, but let's just exit backwards. Gets us back to solver. So we just need to delete, and we can get in there. So just start typing 2,5,0,0,0,0 is equal to, so shift equal 5 times 0.86 to the power of something I don't know. Again, you always just use that button under the red one. Hit equals. Now don't make that mistake of not hitting solve. You'll see it's still got the answer from last time in there, that 31 years. It won't give you an answer until after you've hit solve, so you have to hit solve. And here we go. We've got a value for our time. That's roughly 4.6. So we might say here that t is equal to 4.6 years. So in less than 5 years, he's lost half the value on that car. Probably not a good investment, but I'm sure he's having fun driving it around. So again, you can use solver, you can use your graphics calculator and the graph function in gsolve, you can use heaps of things, even algebra here, using your log functions to solve for this. And don't make the mistake of ever trying to find the variable of like trying to find a t or a p. You always just use the button under the red one for your variable when you're entering stuff in your calculator. So remember, if it's increasing, you convert it to a decimal and add to 1. If it's decreasing, you convert it to decimal and take it away from 1.